Thank you to D-Wave for the opportunity to come out and speak with you today. One of the things we're going to talk to you about a little bit to start out with is Unisys and who we are. Now, a lot of you that I've talked to over the last couple of days, one of the biggest questions is, I didn't realize Unisys was in this space. Well, the reason why we're in this space is simply because over the last 150 years as a company, we have shown and proven our passion for making sure that our customers are successful in what they do and providing the business solutions and technology to help them be successful and in their pursuit of excellence, not only for their companies, but for their end users and their clients as well. And so as we talk today, we're going to introduce you to our logistics optimization solutions using a hybrid quantum and classical optimizer to go and solve some of the more complex and some of the more exciting solutions that we see and problems that we see in logistics today. So looking across our organization, we have been supporting our logistics clients, our air cargo customers, as well as our supply chain management companies with solutions for over 40 years. Now, that has manifested in several different ways, from creating a cargo management and logistics management systems to help our clients capture the data and use that to plan routes, plan fleet management, as well as manage their cargo capacity and provide those services to their clients. And then leading into our cargo portal services that allows our clients to then go and actually market and provide freight forwarders with a means of going in and actually booking capacity and going in and managing across a partner network for that capacity without having to go to multiple applications and providing a single pane of glass to go and do that. So with that passion to help our clients succeed, our approach and our motivation to doing that is we tend to innovate with a purpose, making sure that whatever solution we go and we provide out there, it's usable not only to our clients, but out to a larger marketplace, and it's solving a need that we see for multiple clients in multiple regions of the world. And so about a year and a half ago, we started to partner with D-Wave around quantum. And one of the things that we learned very quickly is the power and speed of quantum. So we took a classical problem within the logistics industry that would take traditional computers 7 years to solve. And using quantum annealing, we were able to solve that in 7 seconds. Now, one of the advantages that provides us, right, and you can see here that we use pre-trained data models. Now, one of the advantages we have of being in the industry and having experience we have over 40 years is we have a lot of knowledge of process, personas, as well as the data that is needed to power these industries and these processes and to get the results that our clients are looking for. Now, with this experiment that we did, you can see that we had a lot of viable combinations of solutions. Now, part of that is because within the logistics industry, as you know, when you get down to the piece level tracking, you get down to the sheer number of airplane types, the capacity of those airlines, the types of packages, the prioritizations of those, there's a huge number of constraints that happen that come with these particular problems and the complexity that it brings to this particular industry. And so as we went in and we started to look at the practical application of this, to build this tool for our clients, this optimization tool, we actually went in and it forced us, and one of the learnings is it forced us to better to better define the problem set, and the data that we needed in order to solve those particular problems. So rather than trying to say, hey, we've got 1,000 different airplanes out there with 1,000 different configurations, we need to go in and look at a very specific problem set, very specific use cases, so that we could provide that value back to our clients. And so what we did is we started to look very specifically at the supply chain and to the providers providing that transportation capacity. And we started with our air transportation. And so one of the things that we have found and doing our market research is that today there are shifting customer expectations. So since COVID, it's all about convenience. Can I get it now? And it's just-in-time delivery. We hear that phrase a lot, right? So how do we consistently provide that just-in-time delivery? And in the e-commerce marketplace, there's a phenomenon going on right now with Temu and Shein and other suppliers where with the internet, it's actually empowering a global marketplace for people to purchase and receive goods. So rather than going to your local store or maybe a ship-to-store mentality where you go and get it, we now have a global marketplace as consumers that we can go and purchase from. Well, the challenge that then comes to that is, I buy it today, I want it tomorrow. Well, it may be coming from China, it may be coming from Europe, it may be coming from some other location. So just the sheer amount of data and constraints that comes with planning that and making sure that the predictability and the accountability of those people providing the goods is there for the consumers that we have today. Now you couple that with increased shipping costs and the complexities of managing that network of capacity, and whether it come by plane, train, automobile, right? And getting that package from door to door, it can get pretty expensive, especially with the rising costs of fuel and other things in order to make that happen. So we all see the news, we all understand and feel the pains of the economy of the way that we have it today, right? Rising costs, stagnant incomes, things of that nature, right? So how do we go and make an affordable solution with the power to push through these complexities? The other thing that we see is diverse data sources, okay? Most of the people I've talked to at the conference, especially the solution providers, my favorite question to ask is, what is one of your biggest challenges? Well, it's the same challenge that we have today, capturing the data needed to accurately and consistently solve the problems that we're trying to reach, right? So having all the compute power in the world doesn't necessarily solve the problem unless we have the data. So how do we go and capture that data consistently? Or if we don't have the data, how do we get that generated and captured, right? So looking at the technology stacks that we have available today with our generative AI, predictive analytics, as well as the power of quantum computing, we can start to fill in some of those data gaps. And so now, what we used to call dark data, such as knowledge that only comes from experience. Or there was an example somebody gave me today where, you've got pilots that are flying airplanes and they're writing down their travel. And so you've got data on the backs of napkins and on notebooks, right? How do you capture that data? How do you fill in those gaps? So it's a combination of these technologies that is enabling us to actually go and do that and have much more accurate models, and to also pre-train those models with the purpose of providing value. So in my career, over the last 25 years, as a consultant and as a business process engineer, I have been pursuing or helping our clients pursue what we like to call the future of work. And essentially what the future of work is, it is the most effective and efficient collaboration and combination of people, process, tools, and data. And how do we do that effectively? And how do we provide that power, that balance, and that value back to our clients and our customers? And it's the pursuit of that, future of work, the pursuit and that passion that we have at Unisys that has led us into the quantum world and why we're standing up here today. It's helping to provide those solutions to our clients and to show the value. So, one of the use cases that we are currently working to solve is around multimodal routing optimization, or what we like to call MMRO. And so when we look at the complexities that comes with this problem, you can start to draw a correlation between the classical computing and the classical optimization, and then the need for the additional power of quantum in order for us to go and solve for the SLAs. We talked about the demand for speed within the shipping industry, the demand for accuracy, because that's the expectation of the end customer today. So when you think about your start location, your destination, and all of the activities that happen from point A to point B, such as the shippers planning boxes, planning their routes, who are their partners for airlines, shipping, trucking, what's the best route to go and do that, and then who has capacity available on what days, what's that cost. We talk about compliance and sustainability, and all of these constraints and all of these variables and complications we have to take into consideration for that end-to-end planning. So that makes for very complex math, very complex computing that needs to happen in a very short amount of time. So just to give an example, a lot of our air cargo clients utilize both freighters and passenger flights to ship air cargo from point A to point B. Well, I recently, on a flight from Dallas to Salt Lake a couple of weeks ago, experienced one of the challenges for planning. So with a PAX flight, the capacity for cargo typically is released only a couple of hours between when the booking comes in and when the flight leaves. Because they take in its passengers and baggage first, and then cargo comes after. And so one of the things that we learned on this flight is that I actually, when I flew in to Salt Lake and I arrived, there's about 100 of us standing at the baggage claim. And we stood there for about 45 minutes. At that point, we started to trickle over to the baggage claim saying, hey, where's our baggage? Well, the guy at the baggage claim counter says, well, we had a weights and balances issue because we had preloaded cargo on the plane going to the next destination, and with the baggage coming on, our weights and balances were thrown off. So we took them off. They'll be here in an hour and a half, and of course, with the delivery time, about 6 hours later, I was able to get my bags. So it's understanding and being able to predict these types of scenarios, but it's also around the exception handling. So if you do have a compliance challenge like this or a weights and balances issue, where it typically takes about 30 minutes to plan cargo on a flight, when you have to react to a situation in a very short amount of time to not impact your core business around these passenger flights, how do you then achieve that speed? How do you then achieve that? And the answer is more compute power. Going through all of these complex simulations and really understanding how to utilize the power of quantum to be able to solve for these going forward. So now, when we talk about it, one of the things that we learned through our POC process with D-Wave is, and we've heard it over the last couple of days, and we have validated those results, that not every problem is a quantum problem. Classical computing is very good at a certain level of complexity. So when you want that power and need that power, you want to have that on demand. We have found edge cases. We ran into one again this morning where we have, let's say, 4,000 packages on a flight, and just the combination of being able to plan that capacity, and you can turn that package in however many different ways to load it on a ULD, and if you do that across 35 ULDs, we found a scenario where for viable combinations and viable load patterns for this airplane, the solution had over, the number of combinations, viable combinations, had over 1 million zeros that we had to then go and consolidate that down into the best, most efficient, and it took a really long time with the classical compute, right? So being able to then go and utilize that on-demand power, and through the Enable It and the LEAP program that D-Wave has today, you can then go and call up that power when needed. The other thing that provides you is having that hybrid solution. We're finding that when we put that cost out to our clients, it's that commercial scale that we're looking for, right? Making sure that for the additional cost of the additional compute power, it's innovating with a purpose and utilizing that. The other thing too, one of the things that we have found over my 20 years of chasing the future of work, and I've used every technology from RPA to machine learning to BPM, and using those in combination in order to provide efficiency and business process improvement. One of the things that we have found is that there is a ceiling to that ROI. Because as complexity happens and you start to combine multiple technologies, there's only so much compute power and there's only so much value you can provide to the client. So some of these combinations and solutions that we've done in the past actually turn out, even though more accurate, and the value is in the accuracy, it actually turns out that it takes the solutions longer than it takes a human to actually do the work. And so one of the things that we see the advantage to quantum going forward is that we can augment the current stack that we have today, not only for powering applications, but also in pure compute power, to be able to break that ceiling and to go in and take the risk in these complex situations and provide the value that we can then turn into value for our clients going forward. So just very quickly for our pilot client, which is Malaysia Airlines, with our capacity optimization solution, we're actually seeing an 83% reduction in the time it takes them to plan their commercial cargo flights. So they're going from about 30 to 45 minutes per flight, and we're actually able to solve that in less than 5 minutes and provide a viable build plan and load plan in compliance, and do that across multiple hops, multiple routes, and be able to provide that, which is for a team of 21 individuals, for planners, we can save about 166,000 hours and provide that back to the client themselves. And then with the accuracy of the model, we're actually seeing right now, and it's an early result, it's about 5% increase in capacity utilization on those flights. So for a client, a mid-market client like Malaysia Airlines, that's a potential revenue uplift of $11 million per year that we're able to provide to them. So how do we integrate quantum into your strategy? This is a conversation point we're having with our clients today, helping them understand when you should use it. And one of it is, first thing is map your use cases. Again, classical computing can do a lot. As Bob mentioned before, we've been doing it for 200 years. So there's been a lot of advancement hypercomputers and other stacks that are out there do a very, very good job of calculating up to a certain complexity. But when you get to those use cases that need the power, we heard from someone yesterday where we typically push those to the side and say, hey, they're too complex, we're not ready for that yet, right? We'll have to go find a solution. Quantum's going to help us break through that and map value to those use cases that were otherwise unobtainable before. Design your compute strategy, right? We at Unisys are really push with our clients the power of a diverse compute strategy. So not only building for IT organizations in the past have reached value through different applications, different tools, because they're each designed to do different things. With the way that we currently are today, with quantum as a service, as well as hyperscaling and cloud, they can now have compute on demand, right? I like to draw the similarity to our freight forwarders, that when they're planning cross-country on a truck and they've got freight, they want to make sure that the right size trailer and the right weight, and that then the truck that they're actually taking it up, they're going over to the mountains, they want to make sure they have a large enough vehicle with a large enough engine to make sure that they can get it there effectively and efficiently. We need to do the same with the power of the compute necessary for our clients to be able to meet those SLAs. And then finally, choose your partner. There are a lot of partners out there today. D-Wave, we saw some of the others as well. And then you also have system integration partners like myself. We've heard from some others as well over the last couple of days with Deloitte. And so choose your partner. Find the one that not only understands your business, the problem and the value you're trying to achieve, but also the best, most effective way to achieve that power. Okay, and that's all I have to help you today. Again, my name is Jeff Smullin. If you have any questions, please let me know. We have one of our quantum scientists with us as well, Bhavika. She's here in the front row. So go ahead and flag us down, and we'd be happy to answer any questions you have.